You may know that the frame rate of analog TV is 30 frames per second, but that is not actually the case. The real frame rate is 29.97 frames per second, in the United States anyway. In order for the TV to work properly, it needs a timing device, but when TV was first introduced, there was no such thing as small and cheap microchips that could keep track of time accurately. The solution to playing video back at a smooth rate was to use the oscillation of AC electricity. In the US, AC oscillates at 60 Hz, so engineers took half of that to keep track of time. In Europe, AC oscillates at only 50 Hz, so that's why TV is 25 frames per second there. This is why cell phone video at night shimmers in Europe due to the difference in film FPS and AC current. TV used to play at exactly 30 frames per second, but when color TV was introduced, the information for color was interfering with the information for sound, and it made the show look terrible. The frame rate was then dropped 0.03 FPS to make it work again. It's fairly common knowledge that video has a frame rate, but is there a such thing as a frame rate of the universe? In order to answer that question, we have to know that there is the smallest distance possible in the universe. The Planck length is generally considered to be the smallest measurable distance possible. To understand why, you have to understand that subatomic particles are expressed in probabilities rather than absolute positions. It is impossible to know precisely where a particle is. On top of that, there is no boundary to where a particle could be theoretically. The chances only get absurdly small. Therefore, an object could theoretically move anywhere if all of its particles decided to move there. The phenomenon of a whole object moving somewhere physically impossible is called quantum tunneling. This applies to you too. There is actually a slight chance that you are on the other side of the world right now. This is so absurdly unlikely it's not even worth noting. Even if you waited billions of years, nothing would even come close to happening on that scale. However, at a very small scale, these probabilities actually matter. At extremely small distances, scientists usually don't think of particles as colliding, but rather interacting. The Planck length is incredibly complex, but it has to do with the smallest measurement that could be possibly taken of a particle using a photon going the speed of light and interacting with that other particle. The Planck length is 1.6 times 10 to the power of -35 meters. A proton is 10 to the power of -15. And you can't even begin to imagine that. The Planck length is about 10 to the power of 20 times smaller than a proton. If the observable universe was a millimeter across, the Planck length would be much smaller than a millimeter inside of that universe. A human is well over halfway the size between a Planck length and the observable universe. How does this relate to the original question of the frame rate of the universe? Well, since the speed of light is finite, about 300 million meters per second, then the frame rate would be the time it takes for light to travel the smallest distance. You can probably guess that this number is going to be absurdly and ludicrously small. It is about 10 to the power of -44 seconds. That is much less than a trillionth of a trillionth of a quadrillionth of a second. This is so fast that you cannot even possibly begin to comprehend it. The universe is only about 4.35 times 10 to the power of 17 seconds old. Then that is much older than you can comprehend. To put it simply, I don't think the universe is going to have a big lag spike anytime soon. On top of that, keep in mind that this is only the smallest measurable time that we know of at the moment. We aren't anywhere close to actually being able to measure the Planck length, and many people suggest that it is possible for events to occur at an even smaller scale. We just couldn't measure them. Thinking about objects that small like we think about the regular world is just not correct. The string theory is an explanation for what occurs at a very small scale, and it essentially states that one-dimensional strings can vibrate into all other fundamental particles. The space-time theory states that quantum foam is the foundation of the universe. Since we don't know exactly what the smallest unit of measurement is, we can't figure out exactly what the smallest unit of time is. And on top of that, we don't know if it will behave anything like the frame rate of a video game. Even if a frame rate of the universe did exist somehow, it would be nearly impossible for us to tell if time froze for 100 years in between frames. centuries may have actually passed between you starting this video and now. You probably immediately think that this seems very unlikely and counterintuitive, and that may just be the best evidence we have against it. The reason why the smallest distance and the smallest time are essentially the same question is because space and time are the same thing. You are actually moving at the speed of light right now, through the fourth dimension of time. Everything is actually moving at the speed of light. Imagine that moving through time is moving north, and the three spatial dimensions are east and west. You can move north without moving east and west. Not only that, but you can only move at a max of the speed of light through any of the dimensions. Therefore, if you move around in the three spatial dimensions, you will age more slowly compared to everyone else. The lesson learned here is that if you want to live a long time, just drive really fast. Actually, don't do that. It won't make any noticeable difference at all. The Earth is moving at an incredibly fast rate. But this doesn't matter at all though, because that's what the theory of relativity is all about. You are moving across the world as much as the world is moving across you. If you drive faster compared to everyone else on Earth, you will live slightly longer. But the Earth moving doesn't matter since everyone else is on it. Light has no mass, and therefore to satisfy the equation E equals mc squared, it has to always be moving, not only from your perspective, but from everyone else's. Therefore, light has to travel at the speed of light only through the spatial dimensions, and therefore it doesn't experience time. The light coming from your light, or the sun, from the light's perspective is in the same frame of time as when it started, whatever that is. From your perspective it isn't though. If light always has to travel at the speed of light, then why does it travel slower through a denser medium? This is actually because the photon gets absorbed and re-emitted in the material, not because the speed of light is actually slower. Even though relativity seems like a complex concept that doesn't apply to the real world, it does. GPS systems actually have to take into account gravity and speed differences between the satellite and your GPS to calculate an accurate position. If time is just another dimension like the three spatial dimensions, does that mean that the past exists? Was 1984 wrong? If I'm traveling north from Orlando to New York, when I arrive in New York, Orlando still exists. So does this mean the past still exists? There are two main thoughts about this, eternalism and presentism. Eternalism is obviously the one that believes the past does exist. Presentism is the one that believes only the present is real. Neither one is proven, but many people who believe in relativity also believe in eternalism. If the past does exist, which it doesn't for sure, then why are we traveling towards the future? The best explanation is the second law of thermodynamics, which states that entropy, or disorder, must increase as time goes on. This makes sense since there are exponentially more states of disorder than order. Traveling backwards in time would break the second law of thermodynamics, which is why the arrow of time points forward. By simply existing, we are adding disorder to the universe, which makes traveling back in time impossible. If the past does exist so, then does the future exist too? Is everything predetermined? Well, it probably isn't. Remember at the beginning of the video I said that very small particles are expressed in probabilities instead of absolute positions? Even if you somehow knew the position of every particle in the universe, you still couldn't predict exactly where they would be in the future because of these probabilities. Therefore, the future is not predetermined, and you truly have free will to change it. With this free will, realize that the closest thing we have to a frame rate is so incredibly fast it's a trillionth of a trillionth of a quadrillionth of a second. We try to make topics like this understandable in terms we are familiar with, like a frame rate, but sometimes the universe just doesn't work that way.